Good morning, everyone. It's just about 16 and a half minutes past 9 o'clock. Those of you from outside South Africa, we're quite cold here now. I'm sitting in a nice warm study. Welcome back. We've got an interesting session today. Jacques and Francis is going to take us through Openshift. As you know, all of our cloud packs these days, that is one of their preferred houses, a platform to go and run on. For those of you also that don't know, if you buy an Openshift, you don't have to run it on Openshift. You can still run our integration pack, the products exactly as you're running it today. You can even run still some of the old versions if they still support it and so on. Then just a reminder, this meeting is recorded, and I will post the recording later into this one of the folders inside here. Just go to today's date, and you can also find all of the older recordings down there. Then without further ado, I'm going to give over to our presenters, Jacques and Francis. If you can just give us a short bio of yourselves before you start, then you can start sharing your screen now, and over to you guys. You're on mute, so you need to unmute yourself if you don't mind.
Okay.
I'm Jacques Volleyn. I've recently joined Red Hat as a solutions architect. Previously, I was with BT as a senior sales engineer. And yes, today our presentation is basically going to be a very high-level technical overview, and hope you guys enjoy it.
Thank you so much.
Can you see my screen? Okay.
So my name is Francis Vivier. I've been at Red Hat for around 2 years. I was previously in consulting within Red Hat. I'm a middleware and application development solution architect. I've been in Linux for around 20 years, involved with Openshift for around 5 years. So I've been around the block with these kind of things. And yeah, that's pretty much it.
Great, thank you, Francis. So I'm going to start the presentation. Okay, so obviously Openshift container platform. We're going to do a basic technical overview. Due to the deployment, configuration, and integration inconsistency between applications, delivering application into production is not a trivial task. Painful deployments lead to not only poor quality of a delivery service, but also to a tendency to avoid the pain by deploying to production less seldom as possible. This in turn results in a larger deployments with more features being delivered at once, and a high risk of things going wrong, which results in more pain, fewer deployments, and obviously so the story goes on. The problem, so the developers have different motivations and concerns than the IT operations. The developer's job is to deliver a change, while IT operations' job is to bring stability. As a result, applications are designed and developed in accordance to the developer's mindsets, and operations requirements are laid over the date at the later stages of delivery, leading to cross-team functional speciality frictions, especially in the end of each of the delivery cycles. So what's the solution of it? Containers provide a consistent environment and tools for both developers and operators to package, deliver, and manage the applications, and therefore simplify the development process regardless of how the application looks and the frameworks developers have used to build the application. They also provide a common set of building blocks that can be reused in any stage of the development to create identical environments for development, testing, staging, and production, thus extending the idea of write once, deploy anywhere. Containers also come to the rescue as a common language between developers and IT operations. Containers can drive a revolutionary change into how these two sides of the IT organization work together. They allow developers and the line of business to their own applications in the form of containers that they then can deploy, maintain, and operate on top of the infrastructure that the op teams provide, without compromising any of the security or compliance. So why do customers choose Red Hat? Innovation is happening in the open source communities, and Red Hat is the best positioned company to help contribute and grow these communities, as well as bring the value of that open innovation to customers. While customers have demands to run applications in many clouds, they also want to reduce the amount of operational complexity that comes from a multi-cloud strategy. Openshift enables customers to have a consistent development and operational experience across any combination of clouds, private or public. There is no single profile of a developer or the way that developer wants to get applications into production. So, Openshift is flexible to enable many ways to empower the developers and allow many types of applications on the platform. Installing Kubernetes and playing around with it for many is not a big issue, but establishing Kubernetes as a platform for the enterprise to run business-critical applications takes a lot more. While it actually is not hard to download and install Kubernetes, getting it really ready for production to run business-critical applications for enterprise takes a lot more. There are a number of things that need to be pieced together, tested, and hardened for operations. At Red Hat, we use 100% open source development model to deliver enterprise products. Our secret sauce is our ability to turn dozens and hundreds of open source projects into production-ready, stable and secure enterprise products that we support over many years. When the community declares a release ready, we typically find hundreds of defects, and we fix it in the corresponding downstream releases. We can do that because we have contributing to Kubernetes and many other projects that Openshift is based on since day one. Red Hat is the largest enterprise developer of Kubernetes, besides the project sponsor, which is Google. So what is Openshift Container Platform? With this foundation of a trusted enterprise Kubernetes platform, we add productive enhancements to deliver application platform with all the components that you need that are fully integrated to build, deploy, and manage containerized applications. In many ways, Openshift 4 is a smarter Kubernetes platform because we've streamlined installation and upgrade experience. You can be up and running and fully configured Kubernetes cluster in less than 15 minutes, and you have everything you need, from metering and monitoring at the cluster level, the application and developer services. Kubernetes updates, security patches, and component updates can be deployed with a single click. Based on Red Hat Enterprise Linux Core OS, Openshift can actually update the underlying operating system and scale the node level, which is particularly useful when you deploy Openshift on a cloud infrastructure, because the entire cluster can scale up and down based on your application needs. So let's look at the architecture of Openshift. So Openshift runs on a variety of infrastructure platforms, from bare metal to private cloud to public cloud. There are two types of hosts in Openshift environments. Workers are where the user workload and various Openshift components will land. Workers can be easily scaled and on cloud providers, even scaled automatically based on cluster capacity. Another type of host is the master. Openshift uses 3 masters for availability and cluster quorum. User workloads do not run in the master environment. So everything runs in pods. The pods is a deployable and schedulable unit in an OpenShift environment. While a pod may have more than one container, all containers in the pod share a single namespace, and a pod receives a single IP address on a software-defined network inside the cluster. etcd is a strong, consistent, distributed key value store that provides a reliable way to store data that needs to be accessed by distributed systems or cluster of machines. etcd is used to keep track of the state of everything in the cluster, from which users are logged in to where the workloads live, and many more. OpenShift is built on Kubernetes, and its core components are still there and directly accessible via the Kubernetes API. OpenShift also brings its own web console with special features for both administrators and developers. OpenShift makes its features available through its own API endpoints, which follow the same standard as other Kubernetes APIs, using custom resource definitions. OpenShift also brings a full lifecycle management solution that deeply integrates, which allows for seamless and automatic cluster upgrades from within the cluster itself. OpenShift includes a number of internal and support infrastructure services that make containers easier to use and scale, like, for instance, DNS. And because these services all run in pods as part of the platform, they can be orchestrated like any other workload and made to run across all hosts in the environment. OpenShift includes the integrated container image registry. This registry is tied into OpenShift's own role-based access control, providing multi-tenancy benefits. Images that are built inside the platform using OpenShift's native build features automatically land in this image registry. Being a fully OCI compliant registry, images created outside the environment can also be placed into the integrated registry as part of the larger software development lifecycle process. OpenShift includes a cluster monitoring solution informed by the best practices of Red Hat's own site resilience engineers. This pre-configured stack based on Prometheus, Grafana, and Alert Manager helps platform administrators understand the health and capacity of the open source OpenShift cluster. OpenShift also includes a log aggregation solution based on Fluent, Elasticsearch, and Kibana. The integrated solution makes it easy to visualize and correlate events for applications that are scaled to many instances, and it too is tied into OpenShift's role-based access control, ensuring that only the right people see the logs they're supposed to. OpenShift extends the Kubernetes ingress capabilities with an integrated router that bridges traffic from outside the cluster into a software-defined network. This routing solution makes it easy for workloads to be exposed and made accessible to consumers that are not inside the cluster. Lastly, regardless of whether a consumer is an administrator or developer, a rich set of web, CLI, and ID integrations, all made possible by Kubernetes and OpenShift APIs, means that people can work in the way that they are most comfortable, thus giving lots of flexibility for developers and admins. Right, so that was an overview of the container platform.
There's one question on the chat.
Yes.
there's a question in the chat is this a competitor to Docker? If not, how does it compare?
Francis, I'm going to ask that you maybe answer that question.
Okay, that's fine. So in some ways, you could say it's a competitor to Docker Swarm. So OpenShift is obviously based on Kubernetes at its core, but the major difference that's simple to explain is that OpenShift is a complete platform. It's not just an environment to run your containers; it's also an environment to completely manage your containers with regards to logs, monitoring, and various other components. So what we as Red Hat do is we attach a host of community projects that we obviously support to be able to give you a holistic experience. If you are using many of the other tools, you only get a container platform that's manageable in some regards, but you don't get everything you need to do. So what will happen is, okay, you're running in containers. Now you need to aggregate logs and all those kind of things. Then it becomes a task for you to then manually do that. If something breaks, then you would also need to, with those tools, also have to fix those tools. So we provide a holistic solution that's certified to all work together. So when I get to the demo, I'll go through the various components that's just out of the box, and then what you can enable, and then you'll see where the holistic platform comes together. So
Francis, I think you can maybe start with a demo. Just concept of time. So
yeah, that's fine. So I'll go into that.
There's a comment on the group from Jock that says, having used both OpenShift and Rancher, I would say it's more a competitor for Rancher. We don't have to delve into that right now, but I think we'll be happy to see the demo.
Yes. So let me just try and share.
So I have a question too. Before we begin, is that how much do I have to master Docker or Kubernetes to understand well OpenShift?
So your question is how much do you need to know to be able to use OpenShift?
Yes.
So one of the things, and I'm going to show it in the demo, that we try and provide with all the management interfaces. There's developer consoles, there's admin consoles, that you do not need to be a complete Kubernetes and Docker expert to be able to use the platform. There's a variety of tools that we have in here, and I'm going to touch on all of them. That makes your life a lot easier if you are a developer. If you are a operations person, you also do not need to know everything. You can use the interfaces only if that works for you. If you are more in depth and you want to do more low level things and you prefer the command line, you can do the command line as well. It touches for all of it, and we provide. So if you're just using Kubernetes, you don't get an administration console, all those kind of things. And the only way you do things is via the command line. And we bolted on a user interface to make this easier for you. So you don't need to know everything in depth to just be able to start using it. It's pretty simple to actually use OpenShift to just get off the ground, and then from there you can obviously scale up and get more in depth with the platform. So I'm going to go on to the demo, and then I'll kind of show you some of the features in Openshift. It's not super in depth, just to get you off the ground with some knowledge. So this is just the login screen. So I'm going to log in here. So when we get in here, it's a bit slow at the moment. So in OpenShift 4, we have two sides of the web console. We have an administrator side, which is geared to more operations people. The developers can also understand what's going on here. And we have a developer console. So I'm going to touch the developer console for just a moment. So this is typically an interface that developers would use. Now, I'm going to show you how simple it is. So I'm going to pick a Node.js application, and we are just going to deploy it. And it's a sample application, so it's not complicated. So basically, let's just go back. So this is the options on a developer console that you can deploy by default. You can get super in depth and start doing it on YAML. If you wanted to, you can deploy straight a container. So let's say this was Docker Hub or an internal Docker registry that you have already. You can pick it. You would just simply, I'm not actually going to deploy it, but we can enter the URL that for your Docker container. We can add application names, resources, and a bunch of other things, and it will actually deploy your existing containers for you. But in this example, we are going to just use a catalog. If you are used to using Docker files, you can also specify them in here. But let's go to catalog. And at the moment, we haven't searched for anything, but we are going to go to languages. We are going to go to JavaScript. Why doesn't it search? Right, so we don't care about that. So I'll get into what this operator backed is at the moment in a little bit. So I'm just going to choose, okay, I want a Node.js application. You click on it, you say, okay, I want to create. And in this example, it gives you a sample repository that lives on GitHub. And we are just going to create this application. It will ask us a few questions. We can choose a variety of builder images. So these are images that exist in OpenShift that knows how to build a Node.js application. In this example, it says 12. So this is for Node.js 12. We can also, if you have older things, Node.js 10. And technically, you can also use Node.js 8 if that's what you wanted to use, but we will just use that for now. So we are going to copy. That's not what I want. So we are going to try a sample directory, which is just a Node.js example. We can call this application whatever we want. So this application name is with regards to the objects created in OpenShift. So it would be a deployment, a root, and that kind of thing. And I'll touch on what those are in a little bit. We can ignore the pipelines. I'll demo that in a little bit. So this is just the name of the container called Node.js. We can pick if we want to use deployments or deployment configs. So deployment configs is a deployment mechanism that comes from OpenShift originally. In OpenShift 3.11, we added more support for deployments. And this comes down to the operators. So deployment is what Kubernetes uses by default. So in this case, we can just use a deployment. It doesn't really make a difference for what we wanted to do, right? So we can create a root if we wanted to. In this example, I'll leave this as blank. We can choose the port. We know the port is port 8080 because it actually detects it from the template that I'm using. We can change things in our build configuration. I just want to go up quickly. We can also secure the route. So a route is basically a mechanism of ingressing traffic into the OpenShift cluster. So you can pick, let's say, a REST or a web application. That must be accessible by clients, and you can expose those. If you are using, let's say, a more middleware application that is not supposed to be accessible to the outside world, then you can choose to not secure it. Servers inside a project can still access it. So you've got a web application communicating to a middleware application. They can still communicate within the cluster to one another. So you can actually think of it as a firewalled environment. In an old architecture, you would have a firewall machine, or you would have a firewall, something like a web application in a DMZ, a middleware application in another network, and a database application in a third network. And you would control firewalls between them. In OpenShift, you can achieve exactly the same thing, but within one platform without having multiple networks. We can have build configuration steps, so we can create webhooks. So if you're using GitHub or GitLab or any other source code management, you can create a webhook on there so that every time someone commits code, you can actually run this build. That is one way of running builds. The other way is obviously pipelines. We can also configure the deployment. So in this example, there's two steps to auto deploy when there's changes to images or there's changes to the configuration. Then there's also environment variables. So let's say your application needs an environment variable for, I'm going to use, for example, SQL Server. The Microsoft container requires you to accept a license agreement on startup. So you can actually add it as an environment variable to do that, that acknowledgement. I'll touch on scaling a bit later, so I'm not going to go too far into there. Then we've got resource limits. So there's CPU requests, CPU limits, memory requests, and memory limits. And basically what these mean, a request is a guaranteed resource allocation to your container. And this is per container deployment. So if you had to scale them up to 2 or 3, the request is guaranteed per iteration of the scaling unit. Limit means what is your burstable amount. So on CPU, you might have a request of half a CPU, and that's guaranteed to you. But you can say, well, your limit is 1 CPU. So you can actually go above half a CPU, but you cannot exceed the limit. So, but you also do not have a guarantee of that limit. And this is basically a control mechanism that a single application that goes rogue on your cluster cannot actually interfere with any other workload, should that be the case. Memory works on exactly the same basis. And then labels is just basically you can label your deployments. And these are useful for selecting everything in a project or namespace that's associated with this label. So you can have multiple applications with the same label because they make up a bigger application. So let's say mobile application, and you can tag multiple elements to become part of it. So I'm just going to create this. Why is it doing this? Let's just go. Yeah, sorry. From cat to log. I don't know where it's selecting this. I think my browser has a JavaScript Node.js web application. Try the sample. Create it. Let's just see where. I know what's going on. This project is not right. Just give me a moment. So we go into Ibm demo, and then we can do the same. Sorry. Apology. So we're going to add.
Okay. What happened there? Why did you pick another project?
So for some reason, my web browser has cached another project for some unknown reason that doesn't exist. I created a new cluster for this demo, and for some reason, it's just injected it here at the top for project. It didn't. My browser just filled that in, which is slightly annoying. So just going to call it color samples, Node.js app, and you'll see now I can create. Right, so what you will see now is we see this element, and this is what a developer would see. What we can see, the resource is deployment, and it's a Node.js deployment. From here, you'll see there's actually a deployment happening, but it's a bit slow. You'll see it says one pending. Now, the reason why it says one pending is because we are actually building an image from a Git repository. So if we go to builds, we'll see there's a build called Node.js. But what I'm trying to get to is for a developer, they will not actually see all the outputs for the build. But here we can go onto the actual build. And if we want to see what this build is actually doing, we can actually see it's actually cloning this Git repository. It's downloading an image from Red Hat. And now it's actually running a source to image build. So what source to image build means is there's a predefined script for building an image from a Node.js source repository. So it knows if this is Node.js, you need to have an image with npm, and it knows you need to do npm install and all those kind of steps to complete a image build. If this was Java, it would know, okay, you need to use Maven, and then it would do a Maven clean install and all those kind of things. And then it runs the build, it copies the artifacts that was generated into the image. As you will see, it goes into the next step where it says pushing image, and it pushes it to an internal Docker registry within Openshift. And as you can see, this push has been successful. So what we can go back to now is monitoring, not actually monitoring, topology. And you can see we've actually got a deployment Node.js. And it says it is running one pod. So we kind of skipped over it to make things simple in the presentation, but a pod is a logical unit of containers. Now, in this example, there's only one container within the pod, but you can have several containers that form a pod. Let's say this was an application that needed an in-memory database, and it's a one-to-one memory mapping between the application and the in-memory database, let's say for caching purposes. You can have both within a single pod. What will happen is, as soon as we scale these pods, each one of these ones will then also scale all of the containers that form part of that pod. So if there's an in-memory database, then the second one will have its own in-memory database, and they don't actually communicate with each other with the in-memory database. They have nothing to do with each other. The other concept is you say, well, we need them to share. So then you would not package it into a pod. So I'm just going to show you, okay, we are going to go to pods, and we can see there's a single pod here. Now, from here, we can actually go onto this pod, and we can see, okay, we want to see the logs. So we can see We've got an environment, dev mode is false, node env is production. So these are all Node.js environment variables, and these ones are set by default due to this application being a Node.js application. We can also add extra variables if we wanted to, but here we can see the logs for this container. If we need to work on this container, we can also go into a terminal, and we can see here, and we can execute commands. Now, all these commands that we run here are run as non-root, because all containers by default in Openshift runs as non-privileged users. It's the best security for running containers. There are ways and means of enabling a container to run as root if you're really required to do that, but it's not something we recommend. Now, I want to just go back for a moment. Now, if we are going back here. Now, let's say we want to say, well, actually, this application receives a lot of traffic. We need to scale this up. What we're going to do, so this is a manual, what I'm demoing here is a manual step, but we can go, okay, we want to click on the plus button here, and we will go to 4, and as you can see, the dark blue line means that it's already running, and it's ready to accept traffic. The light blue means it's actually still starting up. So what we can do is we can go to pods, and you'll see we have 2 running already, and we have 2 that's creating. Okay, now we have the 3rd one is ready and the 4th one is ready. Now in Openshift, what also happens is if I go into the deployment, and this is a little bit of code just to show you. I don't know if this one has an example of it. No, it doesn't. But what another concept that we can do on these things is we want to edit deployment. Okay, not there. We can add health checks, and it actually, I'm going to scale. Just want to go to its root for a moment. Let's go to topology. I just want to show you this application is working. And you'll see this has actually created a root for us. So in Openshift, roots connect to services. And a service is actually a load balance service that will route you to a corresponding pod within this deployment. So on this level, all your containers that's scaled up is load balance. But then if we want to access a route, we have a single route. And then you can use an external load balancer to load balance between the Openshift routers outside of the cluster. So here's just the example running. There's Node.js application on Openshift. What we can now do is we can say, okay, we want to scale this down again. Affect anything later on. Just want to see, so we've scaled the things down. What we can also see in Openshift, we've got metrics, logging and metrics enabled. So from a developer console, we can see this is just a dashboard of CPU memory, bandwidth, and all those kind of nice things. But we can also see metrics. So we don't actually want to see, we want to see a metric for CPU usage, and this is all built into Openshift as of 4.3 in the main user interface. And what we can see is, okay, we see the CPU usage for the build container and what each Node.js application is using. We can also see the memory usage and all those kind of things. And this is this very small subset because we are working in a developer console. Now, what I'm going to do is I'm going to switch back to administrative console. And I'm going to show you the metrics quickly from this side. So in here, I'm just going to select project. As you can see, there's a lot more options in here. but I'm going to choose project IBM, so I make sure the context that I'm in at the moment is the IBM project. And now we are going to go to monitoring, and I want to say I want to see dashboards. So from here, this is just going to take a moment. So as you can see, this is the monitoring dashboard. In this case, it's by default, it just shows me the etcd nodes. And there's a bunch of monitoring metrics in here. But from here, I can see, okay, I want to see the workloads. And I'll choose the namespace of IBM. I can see what each workload is doing within this project. You can see quotas, memory usage, network utilization, all these kind of things that you would like to see. So you can see if a particular project is actually consuming all your resources in your cluster. This is provided via Prometheus and Grafana, and then a bunch of operators that expose also host metrics to Openshift. So I'll click on this. I don't really need to log in. This is not an error, just a quick environment. And as you can see, we'll be logged in. OpenShift, I'm already logged in, so I can just do this. And everything we saw on the OpenShift UI, we can also see within Grafana.
There's one question on the chat. It says, if I want to use specific hardware drivers, for example, to support audio codecs for audio format conversions, is this done in a YAML file, or must it be done in a terminal, and can it be done with non-root access?
So, what will happen is, this thing is just, it's the first time I'm logging into Grafana here, but it's a bit slow. So, when you are building an image, so let's say you're building a container to do audio conversion, and you need to install drivers. Now, you do not need to be a non-privileged user when building a container. Building containers in OpenShift, so let's say you are doing it with Docker. So what you would need to do is obviously, in that case, use a Docker file to build the image that you need to do. In that container, when you are building, you would say you're running it as root. So you'd go in your Docker file, use a root. You would install anything that you want. Let's say you're using a RAL image, you need to install something with FFmpeg to convert certain things. That, remember, when you are using something like Yum, you need to be root to run it anyways. So you would do it as root. The only thing is, in a Docker file, what is often overlooked is you can switch users. So by default, you are running as root. You would do anything that you need to do, and then you would switch to a non-privileged user. So you would call the user audio converter or something like that. And then after you've done all your installation of packages and drivers and codecs, you would just switch to another user. And the main reason is it's just your final running of your container must not be as root. But when you're creating an image, you do not need to be root. Be a non-privileged user. So you can do everything you need to do as root to build the image, and then at the last step, you would just switch to another user to do what you need to do.
Thank you. Just 1 second, guys. We're at the top of the hour, and I see some of you definitely need to go to some other meetings. But if you want to stay on, I will keep the call open for a little bit longer. Jacques, you can carry on, you know, and with the demo. This is recorded, and also for those links that's in the chat and so on, I will put all of that in the download folder, so we won't lose anything. Please carry on.
Okay, so this is the dashboards for just seeing metrics and that kind of thing. Now I'm going to touch on something in OpenShift. It's not unique to OpenShift 4. It was in Tech Preview and OpenShift 3.11, but it's the core part of what makes OpenShift 4 awesome. And this is operators. So operators is, okay, I'm going to go one step back. So operators is container. They are containers. But what they are containers that have intelligence to make other things in your cluster happen. So legacy, we have a container that just runs a workload. What operators do, they extend the OpenShift and Kubernetes APIs with extra functionality. So when we developed OpenShift 4.4, everything in OpenShift 4.4 is containers. So we do not run a RHEL server on a master node that starts a service that we've installed via Yum and that kind of thing. Everything runs as containers. So we would start the initial cluster container that would actually start up other operators. These operators would then do a whole bunch of other things. As a whole, for example, there's a cluster operator in OpenShift, and this thing makes sure everything starts up correctly. It also handles the upgrading of the cluster. So Jock mentioned in his presentation that the cluster can upgrade itself. So it's got over-the-air updates. You can enable it or you can disable it depending on the organization, but the cluster will upgrade itself. What operators also provide is lifecycle management, and I'll touch on it when we go into just a quick deployment of something. But what it can do is it can actually, in a normal world, you would say, I'm deploying a MySQL database. Now, after you've deployed it, now what needs to happen? I'm actually going to change that example to Postgres. So anyone that's dealt with Postgres in the past knows that when you install a new version of Postgres, there's some scripts you need to run to upgrade your databases to the new version of Postgres. But what an operator does is, as soon as you choose to upgrade to a new version of Postgres, it has the intelligence to say, okay, what steps do I need to do to upgrade the workloads associated with this operator? So it provides a whole lifecycle managed scenario where even if something goes wrong, it will also roll back the changes that was done. So that is the power of operators. Everything in OpenShift is an operator. But for end users, there's extra benefits to this. So if I go into operators and operator hub, there's a whole array of operators. And initially you'll log in here and you'll see there's a whole bunch of, some of it says provided by Red Hat. So these are our operators. But this is not just our operators. If I'll do this, we go to IBM, we'll see that there's also an array of IBM operators. So IBM have been very involved with getting some of these working as well. This might be storage. So if you wanted to have the OpenShift cluster talking to IBM block storage, you can install the operator. It's obviously not supported by Red Hat, but it would then be supported by IBM. And we do not block you from using any community operators. I'm going to just show you. I'll move on quickly afterwards, but let's say we are going to go to MQ Streams. Streams. Why is it not? Okay, I'm just in the wrong place. All items, streams. MQ Streams. So this is just our implementation of Kafka, but you can also see this event streams by IBM, which is also Kafka. But you can see the capabilities that's provided into this is basic install, seamless upgrades, full life cycle, and deep insight. So it means that there's monitoring as well. Now, to do this, I'm just going to say create subscription. We can choose, well, we want to provide this to all projects or to specific projects. And this means that if you are blocking it to one project, is if you're choosing to upgrade, it will only apply the upgrades for Kafka to that project and not everyone. But let's say you want to do one upgrade for everyone, then you can also do that. And all I'm going to do is I'm going to click subscribe. It's already, you'll see there's already an operator called Pipelines. And the installed operator will actually happen in a few minutes. It just has to download images. And I'll come back to that just to speed this up. But I was thinking of how to actually demo you Pipelines. So I'm actually going to show you the new Openshift Pipelines. It's currently in dev preview, but this is how we envisage pipelines in Openshift to work in future.
Francis, just one question here.
Yeah.
Shouldn't we do this in another session? You know, we're 10 minutes over time already, and I see a lot of the guys has dropped off. And there's one more question as well that maybe we can handle. It says, for topologies with corporate firewall, how do you handle security? Do you need to set up IP tables or port forwarding or open ports per configuration file?
So I can quickly explain that to you. So let's say we've got projects and we create a project called DB. So this is for databases. All right. Then we can create another project for middleware and all those kind of things. Middleware connects to database and all that kind of thing. So from a networking thing, you'll see there's network policies. So network policy says, okay, I want to create a network policy. So I can say we allow ingress from project where the label matches project name is my project. So here we can say call middleware. And we can do also on pods. And in this case, I'm just going to do it. And we say we have port 6379. And so let's say to port 8080. Or it's actually not. So let's say port 3390 or something. So this is your database port. So we can actually say we allow a policy that a project coming from that's labeled middleware can come to database. But we can also change the label to name. So the project name must be middleware. And then it will only allow the middleware project to connect to this. And this is done via IP tables. So as soon as you do this, you create, the IP tables rule is applied across the cluster. So what will happen is no projects in Openshift by default can connect to each other. And this will do a rule that says, well, that project can connect to me. So on an IP tables level, your firewall is completely controlled for that kind of scenario. It does not work in the legacy world of there's a network, a specific network for databases and all those kind of things. There is functionality that's just coming to Openshift where we can have multiple VLANs, but it's completely out of scope for this. And I'm running in AWS, so I cannot actually show it. I'll need to do it on a different environment. But there is functionality coming in that also allows that if it is absolutely required. So we can actually use multiple VLANs for things as well.
Excellent. I'm going to have to play Big Daddy here and say maybe this is the end of our demo for now, but I think there's definitely scope for another good demo if we want to do operators and CI/CD pipelines. If you don't mind, I'm going to push on your button again in the very near future, and then we can do another demo there. Guys on the call, I've got 26 left. You know, we were 52 at one stage, so I think most guys has got some other meetings out there. There's one more question from Stephanie, but I will contact you directly and maybe we can get an answer for that. Also, I will take the questions and the links that was in the chat session. I will make sure I upload it to the download folder. Guys, anybody on the line still that's got an urgent question?
Francois, it's Andrew HC. I just wanted to say that if there is anything that anybody wants to see more from a Red Hat perspective, please do reach out, either to yourself or to me, and we can definitely get you in contact with the Red Hat team and get into more detail, either specifically or to a wider audience. But definitely do reach out.
100%. Thank you, Andrew. Okay, guys, then, and to my two presenters, Jacques and Francis, thank you. That was excellent. In fact, I've already got a question or a comment in the chat that says, I am more interested in the pipeline, okay? So we will pull you guys in to see if we can do another one soon. Everybody on the call, thank you so much. Have a lovely day. Keep safe.
Okay, thank you.
Thank you, everybody.